Okay, so welcome to everybody, and a special welcome to our guests from abroad, from the universities members of the Transform for Europe Alliance. This is an alliance of 10 European universities that have joined their forces to create a common multilingual campus in order to take care of the future of our regions, countries, and all Europe. The University of Trieste is hosting its first T4U week till the 9th of June. It is an international event which is part of this project, Transform for Europe. The theme of this year is Transborder Europe. The theme will be explored in seminars and workshops addressed to the delegation of students, lecturers, and administrative staff of this university. So this week we have almost 100 guests in Trieste from the 9 European countries where the partner universities are based, which are France, Germany, Spain, Portugal, Poland, Bulgaria, Estonia, Lithuania, and Slovenia. Today we are in a particular place, which is called Stazione Roger, in the center of the city of Trieste, and it is a perfect place for the theme that we will explore today with our guests. Mobility and decarbonization, the EU's challenge for 2035. Because this place, it's an ex-petrol pump that was converted into a social place with a bar and a small conference hall. Today we will propose for the second time an open dual lecture, which is an attempt to bring together academia and business and make them dialogue. This open dual lecture has two main objectives: to make it clear that the problem is the same from both the side, and to try to share a common language about the most important topics of the future. My name is Giulia Basso. I'm a journalist from the local newspaper of Trieste, Il Piccolo. And this afternoon we invited two speakers. One from the academia, which is Professor Mauro Reini. Is a professor of energy conversion systems at the Department of Engineering and Architecture of the University of Trieste. And one from industry, which is Dr. Denitsa Gavrilova from Bulgaria, from Sofia. She's a highly experienced product manager with extensive data, machine learning, and business strategy expertise with global clients. But she is also an assistant professor at the Faculty of Economics and Business Administration of Sofia University. So we will speak about the challenges that energy is facing today, and in particular about mobility and decarbonization. We will have in mind the three focus areas that Transform for Europe project have, which is digital transformation and smart regions, environmental transformation and sustainability, and societal transformation, community building, and inclusion. So the format of the event will be that I'm going to ask three questions, one for each of these points to our guests, and let them both answer. And after this, if the public have some questions, there will be space also for these questions. So let's start with the first pillar, digital transformation and smart regions. And we start with you, Dr. Gavrilova. So the question is, how can digital technologies, data analytics, and artificial intelligence be leveraged to improve mobility and advance decarbonization efforts in smart regions?
First of all, thank you for the invitation, and I'm really pleased to be part of this huge event. Starting with the digitalization most of all helps to track better what's going on in the world. And by tracking this, I can give an example with what are the carbon levels that are produced each day. For example, in the more advanced countries like Europe, there is very good data about this. So this data could be incorporated in everything that we do in the business and to show this to the end user. I mean, because the field that I'm working is platforms for charge points for electric vehicles. At the end of each charging session, we can display to the users what they have saved for the earth. You have seen also in different mobile applications, companies that are already doing this, like airplanes, they tell you how much you saved. So bringing up and raising this awareness of users each day, you make them more engaged to everything that is going on. And also in addition to this is the digitalization helps in with the Internet of Things for this real-time data tracking. So it's yeah, this is the first part. The second part with the artificial intelligence is more complex and more exciting to me, I would say, because the artificial intelligence can bring the things to a different level. What I mean, everybody of you is aware of the automatic cars that we would like to have. This will not help only for people not to drive their cars and read books or anything like this, but this could have a direct impact on the traffic jams, to reduce traffic jams, because the artificial intelligence can program in such a way the traffic to happen and to shift traffic loads to different places. So even for not directly going and buying electric vehicle, you can become part of reducing emissions, carbon emissions, only by being more effective in the way you travel. Because currently you go into a traffic jam and you spend there half an hour, 1 hour, especially in countries like India and etc., which means that you share lots of carbon dioxide while you're just staying and waiting at this place. And what else with the artificial intelligence? There is a very huge and massive topic currently that is related to virtual power plants and utilities in countries like United States, Europe, China, Australia. They would like to take all these utilities to send, it is the so-called demand response. The demand response means that utilities would send signals to reduce load levels at certain time of day, and they will take to companies like ours with the charge points. Now you have to reduce the electricity to these levels because we want to reduce the carbonization now, because users are heavy users at peak times. Let's say when you go back home, you plug in the car or you start cooking or you do something. So this increases the levels. And with why I mentioned artificial intelligence and this huge project of virtual power plants, because with artificial intelligence you can make really good predictions of availability, of usage behavior, and you can share this data with the utilities. So this will create them to make better, to do their data analytics better, and to have better predictions, and with these better signals to send to everybody that is involved in the system. So yeah, this is one of the things that, or the things that I want to mark. Maybe your professor to continue, and I can.
Unfortunately, no. I'm not an expert about artificial intelligence. I am an expert about, quite an expert about renewable energies and energy optimization. I would like to stress this point because, as I told you before, I'm going to make reference to energy transition as the more important point, in my opinion, in every kind of transition we want to deal with. In my opinion, energy transition have 4 pillars. So these 4 pillars are not so very common, very well known at all levels, because for sure we have renewable energy production, that is one point, but we have also electrification, energy storage, and energy integration also as very, very important point. And in my opinion, what my colleagues has commented before is very related to energy integration and electrification. I would like to stress a bit that electrification, as we was commenting in We2 before, electrification is a very important point, because to obtain the energy transition, we have not only to replace the energy, the electric energy that we actually produce with fossil fuels like coal, meat, and so on, but we have to produce much more electric power, because we have to replace also a lot of applications where the fossil fuel are used directly. So electrification means this, that there will be a lot of new additional electrical device, for instance, heat pump for heating. And in a so complex electric world, we have a lot of new consumer, but we have also a lot of potential producer, because we have local production with a solar panel, or we have some production that is not controlled by the demand, but it is controlled by the event, by the wind, or by the sun, or by the weather of a place. So in this, to this regard, the artificial intelligence may help a lot, I believe, even if I'm not an expert, because when we try to write an optimization problem for this kind of system, the problem becomes very complex from a mathematical point of view, because we have a lot of variables, we have a lot of components. For instance, different users, different building. If we want, we can add industry, cars, and charging station, and so on. And we have a lot of potential supplier. So to put in correspondence all these things is converted. We can write a problem. We know how to describe all these components, but then the problem is very big, and it requires, for instance, in the approach we use, that is a linear optimization problem, mixed integer optimization problem, that require a lot of time, hours of computational effort for a small community of 6-8 buildings. So if we want to optimize the energy flows in a city, or for a fleet of vehicles, or something this, cannot be done moment by moment. You need to have a forecasting system, and this forecasting system may be, I believe, obtained by using artificial intelligence and machine learning. So this is a point, in my opinion, where the energy transition can be helped a lot by artificial intelligence. And I want to stress only a thing in which I believe a lot, that is technology integration, because usually we are familiar with having one supplying system for each need. So we have a boiler for hot water or for space heating. We have the grid for electric power. We have air conditioning system for cooling and so on. But in reality, all these devices produce more than one kind of energy. For instance, power system, power plant produces also a lot of heat. When you have a cooling machine, also this cooling machine usually produces an important amount of water at an intermediate temperature, something like 50 Celsius degree, 40 Celsius degree. So the integration of all these different technologies in one total energy system, let's say, is also an important point in view of reducing total consumption and achieving a small environmental impact. But the problem is that when you have a complex object, to optimize the energy flows is very complex, and you have to identify some strategies. If the system is relatively simple, you can face with this technique, like the techniques we use, integer programming or mixed integer linear programming. But when you have tanks and tanks components, tanks and tanks users, this is not possible, because this imply a too big computational effort. And this is a way in which I believe artificial intelligence and machine learning may help. Okay.
If I'm something in this direction, we have lots of fluctuations, because when you set electricity, we have times when we produce more than it's needed, and then we have times when people go home or they need more electricity. So with artificial intelligence, another goal is to make this curve more flat, not to have those to be able to predict and to shift people and to give incentives when when it's better for them to use those electricity levels. And another topic that is widely discussed, along with virtual power plants, I don't know if you have heard of vehicle to grid. These are the electric vehicles to give back electricity to the grid. So by exactly having these tons of data, big data, analyzing it and creating the proper models that could send the incentives and signals to the end user to know, and by making through the digitalization and digital world, these end users aware what they should do and how they should behave in this environment, or more environmentally friendly way, we will achieve the goal of the decarbonization that we are striving for. Because now we are discussing, this is a hot topic in Europe, in the United States, in parts of Asia, but what about the rest of the world? As we were discussing even prior to the discussion here, that those people, at least they have this access to internet with their phones and etc. So if we start discussing more and stressing more, and with, as I said, Internet of Things or whatever we share with them as a result of the analytics part, this will make, in my personal opinion, huge impact, because the users are the main drivers of everything. I'll give us statistics, for example, that for last year, people have spent 425 billions to buy electric vehicles. Only 10% of this investment, this 425 billions, is subsidized by governments. So people has this awareness already in the more developed countries. We need to bring it to the other countries. Yeah.
Thank you both. Okay, now let's move on the second pillar, which is environmental transformation and sustainability. And let's reverse the order of the speakers. So I'll ask Professor Reini to answer first. What initiatives could be taken to promote the use of zero carbon fuels in the transportation sector?
Okay, thank you. Uh, I have to admit that I have a vision of these green fuels that I share it with some colleagues, but not all of them. And the idea is this. What is a green fuel, a zero carbon fuel? You have to start from some green energy. You have to produce it, for instance, with a solar plant or with a wind turbine or some other renewables technology. And then when you have this electric power, you have to use this power for producing a fuel. For instance, green ammonia, green hydrogen, liquid green hydrogen. There are a lot. There are various possible candidates. I have to stress this point because up to now, all these substances that are used in the industry, like hydrogen, ammonia, they are produced from fossil fuels with CO2 emission, with a huge impact on the global warming. So we cannot simply think that switching to hydrogen or switching to ammonia is a benefit. It is a benefit if you use green hydrogen and green ammonia. But to what extent it is a benefit? I told you we have to start from renewable electric energy. And if you start with this electric energy and we put the energy in a battery and then move a car or a small truck or any kind of other applications, we have an efficiency that usually is very high because, okay, we have to pay when solar energy is converted into electric energy because the efficiency of the solar system has some physical restrictions. So we have an efficiency that is more or less about 20-25% as a good value. But then that electric energy is converted into electric power, into power to the vehicle with an efficiency that is quite high, let's say 75%. If we first produce a green fuel, for instance, green methane, synthetic methane, and then we take this methane and use methane for instance, moving a car. We have cars that can be fueled with methane. The efficiency is 3 times lower, 25% more or less, 30% as a maximum. So it is very less efficient to produce green fuel for car mobility, for personal mobility, with respect to the direct usage of electric power, electric energy from a battery. Nevertheless, the green fuel may have, or certainly will have, are expected to have, a very important future for all that kind of applications where battery cannot be on board the vehicle. For instance, ships. Ships are too big for this kind of application for batteries because the battery should be enormous and will take a lot of the volume of the ship. And for the plane, also aircrafts cannot be fueled with electric power up to now because the aircrafts need too much power to take off. So you cannot have all that power at present time, at the present technology. The expectation is that in the near future we are going to have a much higher energy density per unit mass in the battery. So perhaps we are going to have some electric planes in the future. I have seen a couple of videos on YouTube where they show that some vehicles with battery can fly because they are small. They are not an intercontinental plane. So for these applications, ships that are very important. Ships are the real blood system of the economy of the world. So ships are very important, and aircraft, they can be decarbonized only by using some kind of green fuel. For instance, perhaps green ammonia. Green ammonia is something that it is considered as a potential green fuel in the near future. But not for cars. For cars, the problem is solved. Electric cars exist. They work, and they can be also organized for a lot of interesting applications like car to grid and so on. So this is for what concerns the point of green fuels. I believe that another topic that is not, as I told before, so popular, but that is, in my personal opinion, as important as, or even more important than green fuel, is the storage. We need storage at all levels, at the levels of building, community, country, companies, grid. We need to store the electric energy at all levels, and in particular, the bigger storage, or the storage at grid levels, have still to be developed, even if we have some technology. For instance, we have the so-called pumped hydro energy storage. That is an old technology. Here in Italy, we have a lot, not far from here, in the region Friuli Venezia Giulia, and also in the close Veneto. We have some pumped hydropower plant because they were used for a different purpose in the past. But this point of the storage is very important, because when people say that never we will reach a complete renewable energy system all over the world. We cannot feed the whole world with renewable energy. This is true in a certain point of view if you do not consider storages. If you add the storages, you can. At least in principle, it is possible. So I believe that green fuel will be more important. Also, liquid hydrogen may be one of these green fuel, because green hydrogen production is a known technology, even if it is a bit expensive in all terms nowadays. But also the point of energy storage will be developed both from industrial and research point of view.
Thank you.
I want to give a little bit of context before answering directly the question. I don't know a little bit of statistics. So currently 42 gigatons of CO2 are emitted in the atmosphere, from which you know that in the transport it's 28% is responsible for this, the biggest sector. But out of these 28%, only 10% are the electric vehicle, not the electric vehicles, the cars with internal combustion engines. The other ones are exactly like Professor Reini said, ships and airplanes. Going, because customers are very aware of cars, and this is the thing that they can do. But still, there are things that are happening not in the right direction there. What I mean, for example, people prefer to buy SUVs. From the electric vehicles, 60% of the vehicles are SUVs. Those 60% they have larger batteries. The batteries are 75% larger than small and medium vehicles, which means that this implies 70% more critical minerals, because the lithium-ion batteries now are created from those critical minerals. They are the researchers, and actually not one step after the research, you might have heard of batteries that are sodium-ion batteries and lithium iron phosphorus, but phosphorus it's used for the food industry, so it's not good to go there because it's also a scarce resource. But unfortunately, they deliver half the power of the lithium-ion battery. So about the transportation, I think that we should begin with the small steps. So to change the mindset of how vehicles should be used, for example, which means that it's not like we are replacing the vehicles with internal combustion engine directly with electric vehicles. You should change your mindset, how you travel, how you use the transportation, which implies the governments to have a good policy towards making the public transport also to reach zero carbon emissions. There is actually a zero emission declaration between 27 countries that have this goal for 240 year to reach this this goal of zero emission when it comes to public. But yeah, because people can use other types of transportation. Let's say in summer, 2 wheels and 3 wheels. This is, or to have a share vehicles, which becomes common in Europe as well. Not to take, I want to drive a SUV, because you still contribute. You have seen that the levels of CO2, they do not decrease. They decreased only during COVID. But then last year they increased again with 0.9. Why? Because everybody went back to normal behavior of driving their cars. And the other factor was that it was warmer, so more energy for cooling during the summer. Although, fortunately, the winter was more moderate, and this balanced somehow the end outcome of the CO2 emissions. But yeah, first thing about the transport to me is the change of the mindset of people. Then the second thing is governments to invest in public transportation to become or to hit zero emissions. And finally, it's the infrastructure. Because people might be aware of, yeah, I want to do what it's necessary. I'll buy such a vehicle, let's say, or even industries to change and use ships, although for now it's absolutely right that batteries should be enormous for ships or for planes. But even if this happens, there should be an infrastructure for this. And what the statistics show is that China is the first. China sells most vehicles. There 24 million vehicles sold in total. 40% are in China. There are 2.7 million charge points. 1.6 million are in China, because China is heavily investing in infrastructure and in incentives. A vehicle in China costs, small vehicle costs $10,000, while the same vehicle, small vehicle in Europe, starts from $35,000. So it's absolutely. I totally agree that we should go and research better ways, because these sodium ion, and they do not work. They just reduce. Yeah, we are not going to use 7 critical minerals where there is outage, and I'm not even convinced that we'll have sufficient critical minerals to produce all the batteries we need to replace. It's not clear. Or even because they have identified places where we can dig those critical, but this will produce additional carbon dioxide emissions. To sum it up, the research to find new ways of producing batteries, electricity, and the second thing is to change the mindset of how people transport.
Okay, yeah, it sounds.
Yep.
Only a small thing. Obviously, I agree very much, and I am much convinced about the point of infrastructure and the point of public transportation, because public transportation is electric now. We have the technology, we have all the opportunity, so we do not need to have one car per person driving 1 hour in the jam in order of reach the work or the school and so on. I believe that the point of the awareness of people is important, but in my opinion, not so much, because if people have a good alternative that is cheap and comfortable, they are going to choose it. If you have an easy way to go from your home to the work by train or with a tube, I think that at the end you are going to prefer this solution instead of driving in the jam, then struggle for find the parking and so on. The problem is that, for instance, in Italy, we have not a lot of this structure, even in a big city. Public transportation is much more efficient in some country in the northern part of Europe, and there the traffic is less. So in my opinion, this shows clearly that, okay, I like to have my SUV because I like to see it, to have care of it, so on. But when I have to go to my work, I prefer to go easily and in a cheap way.
Yeah, and in most places you do not have a vehicle. Even with these shared vehicles, you do not have a vehicle at hand. You cannot rely. When you have, for example, when you have kids and you have to take them to the school, you cannot give this to the chance whether I'll have a vehicle to take nearby, or I have to wait half an hour or 1 hour to have such. So the policy of the government in this direction to afford this to the citizens is important. Yeah, yeah, that's why I gave China as an example. Now in other countries like the Netherlands, like Norway, like in the United States, last week they announced that they are putting a new investment in infrastructure and shared mobility. So this is, yeah, the government to be active in this direction.
Thank you. And you also anticipated the last question, because the third pillar is societal transformation, community building, and inclusion. And so the question is, how can decarbonization and sustainable mobility be made more inclusive, especially for low-income communities and marginalized groups?
Same, as you prefer.
Okay. Yeah, I can say that, touching upon the topic with the last question, definitely the public transportation is a huge part of bringing the minorities closer to taking part of this decarbonization, because in this way you give them the ability to transport in such zero emission way of transportation. The other, we see that in many countries, and especially in India, the two-wheel and three-wheel, because two wheels, okay, they are vulnerable to weather conditions, but three wheels are not that much, and they are very light. They do not need that much of electricity and energy, and they can be sufficient in small cities. So to me, it's like it's always global approach, but think locally. So a big city with 50 million people has one type of needs. Another small city with 10,000 people has another need. So focusing locally and seeing how to change the way of transportation. And the second thing is to build again infrastructure in residential areas, because the urbanization and cities are developing in such a way that they have they are focusing on building residential areas that lack this infrastructure. So you can have access to lots of things in the very center of a city, of a town, but when you want to go back, and usually minorities live in the outskirts. So the programs of expansion of infrastructure is usually focusing on the very center of the city, and the outskirts are the last. It should be a policy that makes the things happen at one and the same time.
Okay. I would like to add only one point. One point, it's enough. I would like to say something more general. So we have not to think that developing country or low-income peoples have to pass through the same technological development, the same industrial phases we have passed as Western world. There is no any need for they to start with the technology of the 18th century and then going on. They have to be helped. The Western world, the developed world, have to push them to jump directly into the high efficiency technology, into the few polluting technologies for what regard both energy production, I mean solar energy, energy storages, and big solar plants, wind plant, and so on, and also from the, let's say, organization point of view, because when you live in a very big city where all the important institution and activities is in the center, and you have a very, very big neighborhood, where there are very few services, very few infrastructure, and you have to travel a lot to reach the center every day, it is impossible to avoid pollution. So the organization is very important, and we have, but because Western world has thought this alternative. We have discussed, we have developed at a research level from both architecture, technology, organization, management, this solution. We have to make this solution viable for other countries. We have to push them toward a jump directly into a new sustainable world. Otherwise, it is impossible, because otherwise the situation will go on like now, now, where, for instance, Europe, as we was commenting before, Europe is reducing the CO2 emission of Europe as a whole, but all over the world, the emission of CO2 is increasing every year. Disregarding the fact that we discuss about global warming, the problem of extreme meteorological events, and so on. But every day we produce more CO2. So we have to spread all this technology all over the world as soon as possible.
And to add here something, it's not directly related to the question, but to countries being cooperative in one direction, because if we go to a lower level with having the vehicle, having the charge point, and having the user, all of this communication happens through protocols. And what we encounter in business and in daily practice is that companies and organizations in Europe develop one type of protocol. In the United States, another one. In Australia, they try to take from both worlds the best. But at the end, there is a huge confusion and blocker for business to be able to, for business, I mean car manufacturers, what protocol they should implement for systems to communicate properly and to make all these goals achievable. Then the charge point, how to communicate and share IoT information and data to mobile devices, to everything. It's a good thing that there are lots of alliances and agency organizations that are trying to come out with one single solution and standard, but it's still someone comes and decides something, and then the other changes it. So again, going to these small steps to make the impact faster.
Thank you very much. Thank you both. Now we still have time. Now I will ask the public if there is any question. No. Okay. Okay.
I have a stupid question, maybe. So I heard that the artificial intelligence requires a lot of energy to perform good insights. So if you require a lot of energy for artificial intelligence, it is circular and a lot of energy to obtain optimization with the artificial intelligence, but you need a lot of energy to obtain optimization. So it seems a circular referring as in Excel. So it seems maybe it's a stupid question, but
it is indeed, computational power comes indeed with lots of energy to do this, but it's a one-time thing. I mean, because with artificial intelligence, you have to build the model. For the model, you have to supply big data. Once you have the model, you can apply the model to the data onwards without each time to use such big energy for every time you apply the model. So I'm sure that there are steps in this direction to reduce, of course, computational power, to not to use that much of energy, because the last 10 years it was a huge jump in what could be achieved with big data. So now it's the time to make it efficient. Yeah. Because there is a streaming on the mic, everybody
I was not expecting this level of attention. But no, I think he was referring to also the cost of maintaining all of these servers. Because of course, in order to develop an algorithm and to have the performing power for big data to be useful, you need to keep a physical space where you hold all of this data. And that's why, for example, Google is one of the companies that pollutes a lot because they keep a lot of data. So I think sometimes we forget that all of the cool things that we use in our cell phones, we have to store them somewhere, and this takes energy. And sadly, I don't know if all of the times that we are using AI models or machine learning, we are compensating for all of the energy that this takes. So just to bring awareness to that.
I absolutely agree, and I can add to this that um, it's uh, it's a huge step for because I am advocate, or I am very positive about what can be achieved on top of artificial intelligence, not to leave it and destroy the world, of course. But to me, it's what I said as the last thing is that we have made a huge jump. Now we have to go and make it efficient, to find ways not to emit that much CO2, to have the models in place. But yeah.
No, I only noticed that I believe that we are going to use artificial intelligence for more and more things. So if this technology consume a lot of energy, we are going to consume a huge amount of energy, and the part that is consumed for energy optimization is a small part. So the problem is the energy demand of the whole informatic system of the world. I believe that the additional energy consumed for energy optimization is not so much, and in any case, the expectation is that the energy requirement is going down and down. If we think to the first computers, they consume really a lot, and now we have an impressive computational power with a very low energy consumption nowadays. I don't know if this is enough, if we are close to a limit, but I believe that this is not a problem. So for sure, all these informatic structure require energy to stay in operation. But this is not the main energy consumption we have to be aware of.
Okay. Thank you very much to our speakers. Thank you to the public. If there aren't any other question, we can close the meeting, this dual lecture, and we hope to have offered you some food for thought. Thank you very much.
Tu sei del piccolo? Ah, domani articolo sul piccolo. So.